Good. You're welcome to today's tutorials. And before we proceed to whatever we want to do today, I would like us to recap on a little bit of the things that we did the other time in my previous video. So in my previous video, we actually talked about how we can integrate a product of the cos and the sine functions where both the powers of the cos and the sine functions are even. And we came to realize that when we are given a question like this, the focus is to express the functions in such a way that you will get the function to the square of it, so that we can use one of the very important trigonometric identities, which is sine square x plus cos square x equal to 1, to help us simplify the situation. And from there we can use, or we can apply the use substitution method to solve it. And we went through some couple of examples, and I gave you a trial question to solve. And so before we proceed with today's tutorial, I have a trial question for you, and I would like you to solve it. So this is the trial question. This is cos square of 3x dx. Remember that we were able to derive from the first principle how we can get cos of 3x from it. That's very important. So please, this is the answer that you are going to get. This is the answer. It has been provided for you. And I want to give you a hint. Assuming that when you apply the first principle, you are going to get an expression of which we have done in my previous video. So if you have not watched it, please, I'll urge you to go back and then watch it. So in my previous video, you can see a cos square of x, and here we are having a cos square of 3x. And in this case, remember that we did a similar example. If it's cos square of 2x and then you simplify everything in the expression, whatever you want to do, or what you have to do, is to just multiply the expression inside the cos function by what? 2x, or any of the function by 2x. For instance, we came out from the first principle, let's say for let's use this word, let's use this one. I want to get a very simple one of the examples that we did yet. For this one was the example here. We came from an example that the cos square of x will give us 1 over 2 plus 1 over 2 cos of 2x. And therefore, if you are being given cos square of 2x, whatever you want to do, or whatever you have to do, is after simplifying the expression up to this point, you just multiply the expression in the cos function by the 2 over here. The same thing applies to the trial question that I've given to you today. If you finish expressing whatever you do, just multiply whatever expression in the cos function or the sine function by 3, and then you will be good to go. So without wasting much time, I would like us to start today's tutorial. And today's tutorial will be on the integration of integrating product of sines and cosines of a different angle. Sometimes you will be given products of sine and cosine, but they are not going to have an expression inside the bracket as x and x, right? Sometimes we can have maybe with a coefficient which are different. For instance, you can have a product of cos of 3x multiplying sine of 4x. As you can see, these are product of cos and sine function with different angles, and this is what we mean. So since we are going to talk about this come into place, or this emphasize all the importance of the compound angles that I mentioned earlier on in my previous tutorial. So we have to remember something. Yes, so in my previous tutorial, I talked to you, or we discussed this compound angles, and I was saying that we have a sine of a plus b, which is equal to sine of a cos b plus cos of a sine b. The same thing applies to cos a minus b. So if you look at this one, you can see that it's only the sign which changes. So let's look at the second one. The second one is cos of a plus b, and which also gives us cos of a cos b minus sine of a sine b. And the same applies to that of cos of a minus b, of which the sign in between them just changes, right? And we are going to look at how we can use such identities in solving a product of cos and sine function with different angles. So let's take this one for instance. So let's proceed here. To integrate a product of sine or cos, or to integrate a product involving maybe sine of ax and then sine of bx, and also cos of ax and then cos of bx, we use those special angles or these special trigonometric identities which came from the identities that I showed you not long ago. So let's state these special identities here. So for sine of ax and then multiply by another sine of bx, you can use the identity 1/2 cos of a minus b, or multiply by x, minus 1/2 cos of a plus b, or multiply by x. Let's take the other one also. The other one also involves sine of ax cos of multiply by cos of bx, which is equal to 1/2 sine of a minus b multiply by x, and then plus 1/2 sine of a plus b multiply by x. So this is what I mean. Let's take the last identity that we want to talk about. The last identity also constitutes of cos of ax multiply by cos of bx, which is equal to 1/2 cos of a minus b multiply by x. You need to take note of that. Plus 1/2 cos of a plus b multiply by x. These are very important identities, and in fact, you must keep them on your fingertips, and we are going to talk more about these identities. So let's come to think of it, how were we able to come out with these identities? And today we are going to talk about it a little bit. You know, I told you that I will be doing a full tutorial on trigonometric identities, especially compound angles, because I've realized that these angles or these identities are very fundamental for students who are in their calculus class. If you have a solid understanding of these trigonometric identities and other stuffs, you are going to use it a lot, and it's going to help you as you proceed from one level to the other. So let's proceed and know how we can come out with these identities. And I know that some students are there, when they don't know where things comes from, it becomes difficult for them to just grab them up. So let's highlight on them a little bit so that we can proceed with it. Now you can say that this is x and this is x also attached with. So since they are all x, we are assuming that let's say they are x, so they are all the same. So let's instead of writing them x, let's say we are going to write the identities as sine of a multiplied by sine of b, so that everything will be just simple as possible. Or if we like it that way, we can also just let them inside, and then we will be able to do that as well. I don't want the x to confuse. It's just there. You can just, it's more or less representing cos of a minus b. you can also write it as, or maybe cos of ax minus bx. Nothing will change from there. So any of them that you think you'll be comfortable with, you are good to go. So let's start with whatever you want to do. So now let's consider these identities that I showed you previously. So the first identity that I want us to just talk about is sine of a plus b, which is equal to sine of a cos of a, sine of a cos of b, plus cos of a sine of b. Now let's talk about the second one. The second one is sine of a minus b, which is equal to sine of a cos of b minus cos of a sine of b. Now let's look at the third identity. The third identity also talk about cos of a plus b, which is equal to cos of a cos of b minus sine of a sine of b. This is where cos 2a equal to cos square a minus cos of b came from. So when I do a full tutorial on trigonometric analysis, you get to understand it better. And let's look at the last identity that you have to take a look at. The last identity will also comprise of cos of a minus b, which is equal to cos of a cos of b plus sine of a sine of b. Now, looking at whatever we want to do, right? Whatever we want to do. Here, we can decide to attach the x here. Nothing will change, right? X here. But I want everything to be simple. That's why I've just been using the a, b, a, b, a, b. So now, let's try and do this here. Now, in doing this, we want to come out with sine AB, or make sine AB the subject. So in doing that, we can add the first two identities. So when we add the first two identities, we are going to get sine A plus B plus another sine A minus B, right? So this is what we have over here, which is equal to this one. Here is sine A cos B plus sine A cos B. And as you can see here, this cos A sine B, cos A sine B, here is positive, here is negative, it will cancel out. So when it cancels out, now we are going to have sine A cos B plus sine A cos B, which is the same. So in doing that, we can see that we are having sine A plus B, which is plus sine A minus B, which is equal to 2 sine A cos B. And if you want to make sine A cos B the subject, which is sine A cos B the subject, we divide both sides by 2, and we are going to get 1 over 2 sine A plus B plus then sine 1 over 2 sine A minus B. So let's look at those identities I wrote up there to see which of them matches whatever we have derived over here. So looking at these identities, we are having what? Sine A cos B. Sine A cos B. So we now say, assuming that A is equal to AX, and then our B equal to BX. Now we are going to have our sine A cos B, which is equal to half sine A minus B, which is over here, half sine A minus B, and then plus half sine A plus B. We ignore the x, or you can place it there. You can see how we were able to derive it. So basically the same thing applies to the other one. If you want cos this one too as well, you know here is negative, here is positive, so they will cancel out. And then at the end of the day, when you add the other one, we are going to get cos A plus B plus cos A minus B, which is equal to, now we are going to have 2 cos A and then cos B. So in doing this, you can divide both sides by 2, and we are going to get cos A cos B, which is equal to cos A, which is half, that's 1 over 2 cos A plus B, and then plus 1 over 2 cos A minus B. So here we are going to have cos A cos B, which is equal to cos A plus B, that over 2, plus cos A minus B over 2, which is the same as cos AX cos BX, assuming we are having A equal to AX and then B equal to BX, half cos A minus BX and then half cos A plus BX. This is how this identity came from. And looking at the next identities, this is the next identity, and this we are done with the first one was sine A cos B. We have been able to generate that cos A cos B. And the next one, you can also add 2 of the identities, and when you add 2 of the identities, when you look at this place, what are you going to get here? You are going to get cos A minus B and then cos A plus B, and they are all half, right? That's it. And then we are also having sine A minus B and sine A plus B, sine A minus B and sine A plus B. Here we also derive it here, and then let's see how things also go here. Cos A minus B, cos A plus B. You see this one, I have written it twice. I've written this once twice, so basically I think we will ignore that because I've written it twice. There's no need for me to write it twice. So basically that's it. But one of the identities here, you can actually prove it. And how we were able to come out with this. And then I'll leave that one to you as an assignment. Please do well and do it. If you're not able to do it, please comment on the comment section so that I'll come back and then explain a bit or actually give you a detail on how you can go about it. So these are identities that we are supposed to keep on our fingertips so that we can proceed with the next tutorial. But before we end and then come out with our next tutorial, I would like us to evaluate one example. So let's take one example, for instance. Let's evaluate sine of AX cos of BX dx. So in evaluating sine of AX and cos of BX dx, this is actually one of the identities that I've written here. So let's consider a real-time example, or the actual example. So an actual example, like let's evaluate sine of maybe 5x, and then let's evaluate what should I even multiply by, cos of 3x dx. So as you can see here, the AX is our 5x and then the BX is our 3x, which is of different angles. So in this case, we need to apply one of the identities. When we apply one of the identities, if you don't understand anything, you just have to write these identities down. Just write them down, and then you generate them from the first principle. That is, if you cannot keep them in your head. Then one thing that you need to do is actually try and then write them down, these identities down, and then derive from a first principle. And I think if you derive from a first principle, you'll be able to get whatever you want to get, and you will be okay with it. But if you don't practice, at least your practice make a man perfect. So always try and handle things very well. Try and handle things very well. It's very important. Very important. That's very important. So let's look at something here. Okay, let me give you a little bit of tips of how. And when some people were asking how they will be able to come out with this one, the first one. So because of that, I need to actually elaborate a bit on it. So what you need to do is that now when you look at this ones, we are having the right hand side to be 1 over 2 cos of a minus b of x minus 1 over cos of a plus b of x. You can actually combine all the identities up there to just generate different kind of them. So if you want to get this identity, whatever you need to do is that the right hand side is cos. It means that the cos functions were actually combined together to get this identity. So this is the cos function. So when we combine the cos function, we are going to get 2 cos of a cos b, which is not actually the one which is written up there. So what you need to do is that multiply the first identity by negative. When you multiply the first identity by negative, you can see that this first cos a cos b will go to negative, and it will cancel this one out. So when it cancels this one out, this one will turn to positive, and when we add them, we are going to get 2 sine a sine b. And when we are adding this one as well, we are going to get cos a minus b minus cos a plus b. That's what you are seeing over here, right? That's what you are seeing over here, and it's not difficult at all. And so in this case, they multiplied this one, the second one by negative to achieve that. If you multiply the first one by negative, you can also achieve the same thing. Nothing will change. So that's a bit explanation of the second, the one that I gave you as a trial. So please, if you don't get it, go back and then watch the video again. So let's evaluate this. As I said earlier on, these are of different angles, but it's a product of sine and cosine. And in doing that, we can apply the principle, some of the identities that we are fitting there. If you don't remember the special identity that we derive up there, you can write all your identities down. When you write all your identities down, or just ask yourself, which of the identities comes with cos and sine at one of the right-hand side? And when you look at these identities, what can you talk about? What can you talk about? It means that when you look at these identities, the right-hand side, which is sine compound angles, comes with a cos and a sine value combined. So in that case, we can come out and then say that this identity, which is sine 5x cos 3x, is equal to half of sine of what? 2x, right? Plus 1 over 2 sine of 8x. Sine of 8x. Sine of 8x. So that is how we do it. That's how we do it. So basically, you have to consider that this one is your A and this one is your B. So considering that this one is your A and this one is your B, you will be able to come out with whatever you want to do. You'll be able to come out with whatever you want to do. So whatever came is that, you know, the identities are sine of A plus B, and then sine of A minus B. So this A plus B, so 5x plus 3x will give us 8x. That is what is inside one of them here. And then the A minus B is equal to 5x minus 3x, which is giving us 2x. And this is what is inside here. So if you don't understand that one too, please take your time and then reflect on it. So knowing that this is the identity that we are supposed to get, you are good to go. You are going to say that then we are having this integral of sine of 5x cos of 3x dx is equal to integral of, then you replace it with this one that we have derived here, and then we are going to get 1 over 2 sine of 2x plus 1 over 2 cos sine of 8x dx. And at the end of the day, when we integrate it, we are going to get negative 1 on 4 cos 2x minus 1 on 16 cos of 8x plus c. As you can see, this is far simpler and easy to integrate than having it like this way. So please, those identities are very important, so I'll urge you to just keep it on your fingertips. So having understood this, or having now that you understand this example that's just solved, I would like you to actually try your hands on this question. So this is a trial question. Now let's evaluate the integral of cos of 6x and then multiply by cos of 5x dx. This is a very simple example and I'm expecting you to get it right. Please try your hands on it, and then when you are done, you can check your answer over here, and this is your answer. At the end of the day, you are supposed to get 1 over 2 sine of x plus 1 over 22 sine of 11x plus c. This is what you are supposed to get. So please pause the video and rework or work on this example. And one advice that I will give it to you is that mostly sometimes when you cramp the 3 identities, sometimes you find yourself wanting when you meet a different combination of questions. So just know how we are able to actually derive everything from the